Hi, last week we learned how to use a micropipette in the laboratory. Basically, it's an instrument that's about this long. You can hold it in one hand. It's quite small. It's small because its purpose is to measure small liquids of volume smaller than 1 milliliter, which you obviously cannot do with a pipette. So basically, you hold it on one hand. It has a pointy tip at the bottom, and you press the plunger on top to take in certain amounts of liquid, which can be adjusted using another sort of knob on the micropipette. You twist it and you can switch you can see the value of liquid you want to take in on the digital display window. And I noticed that some micropipettes of different brands have a lock feature where you can lock in the value of amount of liquid you want to take in. And I find this feature very useful, as you can avoid humans, how we sometimes we make mistakes, and this will ensure that the volume of liquid we measure will be absolutely certain and that we no mistakes whatsoever. Thank you.
Okay, I'm Annalisa. My metric number is 175282. Okay, last week we have done two activities in one experiment. The first one is manipulating small volumes using micropipettes and also laboratory buffers. Okay, as we all know, micropipettes have their own range, pipetting range, so we do not have to set beyond the pipette's minimum and also maximum values. Okay, there are various types of micropipettes, which is we have to see the color of the micropipettes, which is the white color, yellow, and also blue. Okay, last week we also learned how to collect sample with micropipettes and also how to expel a sample from the micropipettes. Okay, next, the second activities that we have done last week, also how to prepare the phosphate Buffet saline, which consists of reagents such as sodium chloride, potassium chloride, and sodium hydrogen phosphate, and also potassium dihydrogen phosphate. So first we have to dissolve all the reagents into 800 millimeter of distilled water, and the first pH we got is 4.68. So we have to adjust the pH so that it will come to neutral condition, such as 7.4 pH. So first one we get the acidic, so we have to add more basic solution so that it will come to neutral pH. And after that we also calculate how to solve the question provided in the lab manual. Okay, that's all from me. Thank you.
Hello, my name is Raja Aiman and my matrix number is 180878. Okay. Based from our last week practical for labs, we had to prepare this thing called PBS, which is phosphate buffer saline solution. So what is phosphate buffer saline solution? It's a buffer solution in which it is a mixture of weak acid and conjugated base. So this buffer solution is mainly used for biological researches, and such researches includes like a wide variety of biological application in which we can use for recovery of cells, sperm swabs, and even for cell culture and maintenance of protein pH. So over here what we did was we had to prepare PBS itself. So such materials needed include our like volumetric flask, sodium chloride, and whatnot. So I'll just introduce everything here from the procedures. So first we actually have to prepare 8 grams of sodium chloride, and then it's weighed on the weighing balance in the weighing board. And then we repeat step 1 itself with 0.2 grams of potassium chloride, sodium dihydrogen phosphate at 1.44 gram, and then 0.24 gram of potassium dihydrogen phosphate into their respective weight loads. And then with the 4 reagents we have, we mix it all into a beaker, fill that with 500 ml of distilled water. After that, we use a magnetic stirrer in which we stir it by itself, and then we put the probe of a pH meter half into the solution. So after that, we, based from that result, we would attain about 4.6 pH value of the solution. So from there, we have to neutralize it back up to 7.4 pH by adding up 1 mole of sodium hydrogen solution. Sodium hydroxide solution, I'm sorry, of 1 mole. So after that, we mix everything up and then we transfer it back into a volumetric flask, and then we slowly add distilled water until it reaches the graduation marking, which marks at 1000 ml. So from there, that's how we can get a pretty much good phosphate buffer saline solution. That's all from me. Thank you.
Shirley Chin, my matrix number is 180864. In this experiment, I have learned how to manipulate small volumes and laboratory buffer. Okay? Biological samples and reagents used in a biology laboratory are usually in small volumes. Dispensing those volumes require the use of adjustable micropipettes. There are 3 micropipettes I have learned how to use in this experiment, which is come with yellow, white and blue. The white micropipettes can measure about 0.5 to 10 microliter, whereas the yellow can measure 10 to 100 or 20 to 200 microliter. For the blue one, it can measure a bigger volumes, which is 100 to 1000 microliter. So there are some precautions when using this micropipette. Set the pipette volumes only within the range specified for that micropipette. Do not attempt to set a volume beyond the pipette's minimums or maximum volumes. This may damage the micropipette gears, the micrometer gears, sorry. And when using the micropipette, first you must apply a tips. Forgetting to do this, we run the precision piston that measure the liquid volume. And then the next is, always keep a micropipette in a ventricular position when there is a liquid inside it. Do not allow the liquid to accidentally run back into the piston. And then the next is, use your time to control the speed at which the blubber rises after taking up or ejecting the liquid. And then the next thing I would like to tell is the preparation of phosphate buffer saline. In this experiment, 8 grams of sodium chloride and 0.2 grams of potassium chloride, 1.44 grams of disodium hydrogen phosphate, and 0.24 grams of potassium dihydrogen phosphate are prepared using the electric balance. So all these ingredients, all these materials are dissolved in 800 ml of distilled water. The next step is we have to put it in the pH meter to measure the pH volume. The next step is we have to put the stirring bar to stir all the ingredients, to stir all the material to dissolve it. And then the next step is we have to measure the pH volume. The initial pH volume for this experiment was 4.48, and we have to adjust the volume to 7.4. So we have to add 1 more of sodium hydrogen to make up the pH value to 7.4, and also some hydrochloric acid to balance it until the pH value to 7.4. So that's all from me. Thank you.
Hello, my name is Mei. My matric number is 180893. And today I'm going to talk about discussion that is based on the experiment of buffer solution in PBS. And the first thing we need to discuss is this is an error that we made. That is during the neutralization process of the buffer solution, we think that change in pH value is too slow, so we just press very hard, press very strongly. Then all the pH, all the acid, all the sodium hydroxide just went in. Then in the end, the changes in pH value is too fast, and we exceeded the value pH value of 7.4. That is, we reach pH values 8. Therefore, we quickly reverse the effect by adding back 1.0 mole of hydrochloric acid. So the moral value is we have to be patient in doing our experiment, and we need to, especially in this case, we need to drip all the acid or base or alkali slowly drop by drop. And another thing is we need to be aware that when using the pH value, the diode has to be immersed in the half volume of the solution we have in the beaker or in, so that the reading of the pH by the pH meter is precise, because it can detect the most optimal level of ions present in the solution. And the next is when reading those, when taking the reading of those solution, like the volume of the solution, we have to be precise, and so we need to read the reading at our eye level, so that there will not be any error in it. And lastly is when using the electric balance, we have to make sure that we calibrate it before we use it. That's all from me. Thank you.